So what happens when we have a binomial? Well, we're going to FOIL, okay? So distribute twice. Then we have to simplify any radicals, then combine like terms. Let's try a few of these. Are you guys ready? Example 8 says 3 times square root of 2 times a quantity of square root of 10 plus square root of 5. So 3 times square root of 10, students, it will say 3 square root of 10. Remember, the number in front is 1 here, and 1 here, and 1 here, if we don't ever see any number. All right, so 3 times square root of rad 5 is going to be 3 rad 5. In the middle, rad 2 times rad 10. Students, inside numbers can be multiplied with inside numbers, so 2 times rad 10, just like that. So on rad 2 times rad 5 is going to be rad 2 times rad 5. Then let's see if we can simplify. Radical 10, students, cannot simplify because rad 10, it's a 2 times 5, okay? Drop down your 3, rad 5. Now, rad 2 times rad 10, that's going to be 2 times 2. Rad 10 is going to be 2 times 5. Then 2 times 5 on the inside, that is going to get multiplied back out because you can't really simplify anything. This could be simplified out to 2 rad 5, okay? Then drop everything else down, and then we're going to see if we can combine like terms. Now remember, to combine like terms, since these are all square root, we need to look for similar radicands. This is radicand, this is a radicand 10. They are both going to be okay to add. The number on the outside, if you don't see 1, then it's always going to be 1. So 3 plus 1 is going to be 4. This is going to say 4 radical 10. Then this one on the outside and this one on the outside, those can be combined. That's going to say 3 plus 2 on the outside, that's going to say 5, and then the radicand stays as radical 5. Combine. Cannot combine anymore because radicand 10 and radicand 5 are not the same. Let's do this one, number 9 and number 10. Number 9 says 2 rad 3 times radical 3 is going to be 2 radical 3 times 3 on the inside. Then 2 rad 3 times negative 6 rad 5. Then on the outside now, guys, it's going to be negative 12 rad 3 times rad 5. You can write rad 15 if you want, or you can write rad 3 times rad 5 first and then write the next step as rad 15. This one right here, remember, if you don't see a number, it's always 1. So this is going to allow us to say, okay, well, outside numbers 4 and 1, multiply them together. That's going to give us 4. On the inside, rad 5 and rad 3 multiply will give us a 15. So this is going to be 4 square root of 15 if it allows me to write. Oh, come on. Okay. Now last, okay. 4 rad 5 times negative 6 rad 5, students. On the outside, it's going to say negative 24. And remember, sorry guys, my computer was glitchy and it closed down my little page here. Anyway, on the last two terms, 4 rad 5 times negative 6 rad 5 is negative 24. Remember, radicand 5 times radicand 5 is now radicand 25, or you can write 5 times 5 because we know that will reduce down. Okay, so 3 times 3 under the radical, which is rad 9, but we don't really want to multiply that out because we know that is a pair, so that will reduce down to just a 2 times 3. Drop down your 12 rad 15. Actually, you know what? Let's combine those, okay? Because they're both, look at this, rad 15, combine. Negative 12 and 4, students, that's going to be a negative 8 rad 15. Then we know this is a negative 24 times 5. Then this is going to say 6 minus 8 rad 15. Well, 24 times 5, well, 20 times 5 is going to be 100. 4 times 5 is 20, so together 120. Combine like terms, 6 take away negative 120, y'all. It's going to be a negative 114, and then minus 8 rad 15. There isn't anything we can do here because square root of 15 cannot be simplified further. Okay, example 10 says the quantity of 5 minus rad 7 times the quantity of 5 plus rad 7. 5 times 5, y'all, is 25. 5 times square root of 7 is going to be 5 rad 7. Negative rad 7 times 5 is negative 5 rad 7. Negative rad 7, guys, times a positive rad 7 is a negative 7 times 7 because they're both radicands. Okay, so 25, these are exactly the same but opposite signs, so they are going to be dropped. Square root of 7 times 7, that is a pair that can be dropped down. 25 minus 7, that is going to be 18, and we are going to box that up. Now, if you guys pay attention to this example, okay, these are what we call conjugate pairs, right? Conjugate pairs when everything is exactly the same except the signs in the middle. And we studied conjugate pairs before. When you guys multiply binomials and they are conjugates, students, you don't have to multiply the middle because they always ending up canceling. So what you could always do is multiply the first and the last and then simplify from there. Okay, let's go and do some more down here. Okay, so it says rationalize the denominator. Make an equivalent expression with no radicals in your denominator. So on the left side, monomial radical in the denominator. Monomial means one term. First, multiply the numerator and the denominator by the radical expression that will make the radical cancel. Then we always have to simplify. If you have a binomial, students, in the bottom, then you are going to multiply by the conjugate, okay? And the reason we multiply by the conjugate is if we look at this example 10 right here, when you multiply the conjugate, you only have to multiply the first two terms and the last two terms, and the final answer would never end up with a radical. So, all right, let's try this one. Example 11, 12, and 13. These are all monomials, okay, denominator. So 5, oops, I don't need to write copy. Okay, 5 divided by 2 rad 3. We can't really reduce, but we can't have a radical in the bottom. So since it is a square root, we are going to multiply it by square root of 3. This will allow us to say, okay, well, 5 radical 3 times 2 outside. We have now rad 3 times rad 3. Well, rad 3 and 3 on the bottom is now 2 times 3. On the top is now 5 rad 3. That will allow us to reduce down to, multiply out to 5 rad 3 on the top. And then 2 times 3, which is 6 on the bottom. Let's check to see if we can reduce, and we cannot. So let's box that up. Okay, be careful. This is under the rad, and this is outside the rad. They cannot be simplified together, okay? Now 12, remember, look at this. They are under one big radical. So what we could do is rewrite it, students, okay, into 2 little radicals, okay? Then this is a monomial. So we are going to multiply the identical monomial. Whatever we multiply to the bottom, we multiply to the top. So on the bottom is going to say rad 5 times 5. On the top is 2 times 5, which is 10. But on the bottom, students, 2 5s will allow us to take it out. And on the top, rad 10 cannot be simplified. So that will allow us to box it up. On 13, we can simplify first if we want, okay? So first things first, rad 8, y'all, is 2 times 4, okay? Then that's going to say 4, well, square root of 4, that's a perfect square number that can be simplified out to 2. Then we have a 2 left. This could be reduced down to, okay, 4 divided by 2, that's 1 and 2. So this is going to say 2 on the numerator and square root of 2. To rationalize, we are going to multiply by square root of 2. This is going to say, all right, and the bottom is rad 2 times rad 2, which is rad 4. Square root of 4 is really simplified down to 2. On the numerator is 2 rad 2. And yes, we do have to simplify these, 1 and 1. And so we don't really write the 1, students, so we're just going to write square root of 2 and box that up. All right, now what happens when you have binomials on the denominator? Then this is when we have to multiply by the conjugate pairs, okay? The conjugate pair means everything's the same except the sign in the middle will be opposite. So put parentheses around all binomials right now, okay? So multiply this by 5 plus 2 rad 5. What you multiply to the bottom, you multiply to the top, okay? Now on the top, we are going to FOIL as normal. 2 times 5, that's 10. 2 times 2 rad 5, that is going to be 4 rad 5. Rad 5 times 5 is going to be 5 rad 5. Rad 5 times 2 rad 5, students, 2 rad 25, okay? Or you can write this first right now. On the denominator, these are conjugate pairs because everything's exactly the same. So we're just going to multiply the first two terms. 5 times 5 is 25. And then we are going to multiply, hey, if you want to, you can go straight to negative 2 rad 5 times positive rad 5, but I'm going to demonstrate this right now to show you that the middle two terms will cancel. Now, 5 times 2 rad 5, y'all, is going to be 10 rad 5. Then this right here, negative 2 rad 5 times 5 is negative 10 rad 5. Then I'm going to use green. Now, negative 2 rad 5 times a positive 2 rad 5 is negative 4, okay? Rad 5 times 5, aka rad 25. So for this first one, I'm just going to write and show you all of the steps, okay? The next two, I might go a little bit faster. As you can see here on the top, okay, we have a 10. I'm going to drop that down. I will combine those right there. That will give me 9 rad 5. Then the end here, I'm going to have 2 square root of 5 times 5 is going to be 2 times 5. Simplify out. Now, check this out, guys. These two, the middle, and you see they're opposite, so they are going to be gone, okay? So that's going to leave us 25 minus 4. Well, students, rad 5 times 5 is 4 times 5, okay? So let's simplify some more. We are going to say 10 plus 9 rad 5 plus 10 all over 25 minus 20. Yes, you would need to simplify as much as possible. That will give us 20 on the top. 20 plus 9 rad 5, and the denominator, this is going to say 5 because that's what 25 take away 20 is. We can't really simplify anymore because if we look at the numerators here, those cannot be reduced. And so we are going to box this up, okay?